Amazon Redshift. This page here has their tagline, which is a fast, powerful, fully managed petabyte scale data warehouse service in the cloud. Let's talk about Amazon Redshift's architecture. Amazon Redshift's architecture is optimized for data warehousing. They use a variety of innovations to obtain a very high query performance on datasets ranging in size from hundreds of gigabytes to a petabyte or more. It uses a columnar store, which allows them to compress the data and create zone maps to reduce the amount of I/O needed to perform queries. Amazon Redshift also uses MPP architecture, as we've discussed before, parallelizing and distributing SQL operations to take advantage of all available resources. The underlying hardware is designed for high-performance data processing, using local attached storage to maximize throughput between the Intel Xeon E5 processor and drives and the 10 gigabit mesh network to maximize the throughput between nodes. All of this adds up to one thing: speed, as you can clearly tell from how fast that animation flew onto the page. Now let's talk about the scalability of Amazon Redshift. Now with a few clicks in the management console, or a simple API call if you were building your own app, you can easily scale the number of nodes in your data warehouse up or down as your performance or capacity needs change. Amazon Redshift enables you to start with as little as a single 2 terabyte XL node and scale all the way up to a 16 terabyte 8XL nodes for 1.6 petabytes of compressed user data. Amazon Redshift will place your existing cluster into read-only mode, provision a new cluster of your chosen size, and then copy all the data from your old cluster to your new one in parallel. This means that you can continue running queries against your old cluster while the new one is being provisioned. Once your data has been copied to your new cluster, Redshift will automatically redirect your queries to your new cluster and remove the old. That's pretty amazing in how seamless they make it to be able to upgrade from a 2 terabyte single node up to a 16 terabyte 8XL node. You can see the detailed specs here. Really, the main difference between the two is the memory size and the network speeds. At the bottom, I've also included the API listing for the two different types of nodes. Now we'll get to my favorite part about Amazon Redshift, and this is the cost. You can choose on-demand pricing with no upfront costs or long-term commitments, or obtain significantly discounted rates with reserved instance pricing. On-demand pricing starts here at 85 cents an hour for the small 2 terabyte node and $6.80 an hour for the 16 terabyte XL node. With a 1-year commitment on a reserved instance, you get about a 41% savings. For the 2 terabyte node, there is an upfront cost of $2,500, and that gives you about 21.5 cents per hour. And the 16 terabyte node is $20,000 up front with about $1.70 per hour. You can go longer with a 3-year commitment and increase your savings up to 73%. So if you know that you're going to be going with Redshift for a long-term commitment, this is definitely the way to go. The nice part about this is that you can start out for pennies on the dollar and see how the performance is, see how the scalability works, see how the maintenance and administration through their AWS interface is. All of these things you can get a feel for with only spending a really small amount of money and still having up to 2 terabytes in storage. That's a decent sized test, I would say. And then once you have grown out of that and you realize, okay, or you believe that this is the strategy for you, you can move to the higher tiers and start incurring all those savings. So I've been hinting at this a little bit. Let's talk about how easy this is to use. So you can really get started in just a few minutes using the Amazon Management Console. You can also create an app and do API calls. Either way, whatever you're more comfortable with. I personally am more of a Management Console guy. I love that I can just log in and click a few buttons and be up and running in no time. Now when I do that, I can create a cluster, specify the size, choose the node type and my security profile. Amazon does the rest for me. It's really cool. All of the management interface is done through the web, so I love that. I love when tools are made easy for me on the web because I'm much more interested in the analytics and what I can get out of it and how I can actually gain insight than I am how easy or sophisticated an API may be. The next thing that I like to cover about the simplicity of the system is that it's fully managed. So Amazon handles all the work needed to manage, monitor, and scale the warehouse, from monitoring the health to taking backups and applying patches and upgrades. All that headache that you'd have a NOC or a data center team handling before, you can forget about. Now, as I mentioned before, you can add and remove nodes from your cluster as your performance and needs change. By handling all of these time-consuming, labor-intensive tasks, Redshift really frees up the focus on the data and the business insights that you're trying to get out of your BI system. One thing that I've loved and have recently had an experience of dealing with is the automated backup solution. Amazon Redshift has an automated snapshot feature which continuously backs up new data on the cluster to the Amazon S3. That's their storage engine in the cloud as well. Snapshots are incremental and continuous. Amazon stores the snapshots in a predefined period, which can be from 1 to 35 days. You can also take your own snapshots at any time, which is great if you have an upgrade coming or a switch to a new system and you want to take a specific snapshot out of schedule. Now, if you were to go in and delete your cluster, your system snapshots are removed, but your user snapshots are available until you specifically delete them. So if you shut down the system, but you had an old snapshot and wanted to get back to that later on, you could simply boot up a new cluster and restore that old snapshot. The last thing I'll mention about the ease of use for Redshift is the fault tolerance. Fault tolerance is all about reliability, and Redshift has several features in this area that really increase the reliability of the warehouse. All the data is written to a node in your cluster is automatically replicated to other nodes within the cluster, and all the data is continuously backed up to Amazon S3. So while Redshift continuously monitors the health of the cluster, it automatically is replicating the data from failed drives and replaces nodes as necessary. So as I mentioned before, if you had tens of thousands of disks running at the same time, you're almost always going to have one or two that are going down, and Amazon is going to handle all of this for you by continuously distributing the data and copying data over from down nodes into new nodes that it's replacing. Let's talk about security. With Redshift, you can set up AES 256-bit encryption. Now, there are a few parameters that you have to go through, but again, it's all driven through the AWS interface. Now, if you choose to enable encryption of data at rest, all the data written to disk will be encrypted as well as any backups. That's huge because there's a huge security concern about data in the cloud, and this is pretty strong encryption in order to alleviate some of those concerns. Redshift also allows you to set up a firewall. They have their Amazon VPC firewall. And with this, you can control network access to the data warehouse cluster. You can also run Redshift inside of the virtual private cloud to isolate your warehouse in your own virtual network and connect it to your existing IT infrastructure. Lastly, here are the tools that connect directly to Amazon Redshift. Now, I've only highlighted the BI tools here. There are other data integration tools and other systems that talk to it, as well as there's a pretty robust API. So if you really wanted to get into it, you could build your own if you so desired. All right, enough about Amazon. Now let's talk about Google.